Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 10. We're going to be talking about angles regarding circles today. There are circles that are inside the circle, on the circle, and outside the circle. And today we're talking about angles that are on the circle, which are called inscribed angles, okay? So 10.4 is the name of the lesson is use inscribed angles and polygons. Essential question is how do we use inscribed angles of circles and polygons? All right, so an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of a circle. So what does that look like? Let's try to draw a somewhat decent circle here. So let's use inscribed angle. Let's use blue here. So basically it's an angle that's on the circle like this, right? And this little theta right here, this is going to be the angle, okay? It's an angle that's on the circle, and the ends of the angle are on the other side of the circle and touch the circle, okay? So that's an inscribed angle. An intercepted arc is the arc that lies in the interior, interior of an inscribed angle and has endpoints on the angle. So the intercepted arc is going to be basically the part of the circle that touches the ends of the inscribed angle. It's kind of like the angle kind of is the outside. It kind of contains the arc. The intercepted arc is it meets the ends of the inscribed angle. Okay. Inscribed polygon. A polygon where all of its vertices, vertices lie on a circle. So if we have a circle like this, a inscribed polygon, it's going to be something like this. Let's try that a little better, a little bit more random. That's an inscribed polygon, okay, where basically all the points of the polygon are on the circle. And a circumscribed circle is going to be the actual circle, which actually touches all the corners of the polygon. Circle that contains the vertices, vertices of an inscribed polygon. All right, sounds good. Now, this is actually a pretty easy, I think it's a relatively easy idea, so we'll use blue here. So, a measure of an inscribed angle, all right? So, in this case, these boxes are not great, but so measure of angle ADB is going to be 1/2 the measure of arc AB, okay? Or, an easier way to say this is the angle equals 1/2 the arc, or the arc over 2, and the arc equals what? Double the angle. Okay, this is what I would like you to remember in general. I think it's a little bit easier. Okay, so when the angle is on the circle, the angle is half the arc that it meets across from it, right? It's half this arc, or the arc is double the actual inscribed angle that it meets. Okay? All right. So, if you'd like to give this a try, example 1A and B. See if you can figure this out. See if you can figure out what these are. If not, we'll go through them in a second. All right, we're looking for measure of angle S. Okay, so here's angle S right here, right? So we know the angle is half the arc, and the arc is double the angle, right? So what do we have here? Do we have the arc or the angle? We have the arc, which is 60. So are we looking for the angle, or are we looking for the arc? Looking for the angle, right? So the angle is going to be 1/2 of the arc, right? And what's the arc measure? It's half of 60, right? So the measure of angle S is going to be what? It's going to be 30. Half of 60 is 30. And that's it. Okay? Now that we went through that one, let's see if we can figure out B. All right, so in this case, are we looking for the arc or the angle? We're looking for the arc, right? So we're looking for a measure of RQ. RQ is that, so we're looking for the arc. So the arc, let's see, that's weird. What's happening? Okay. So this is a little bit weird here. So in order to figure this out, we have to do something a little bit different. I'm going to erase this. I don't like this. So, so we're not looking for RQ. Well, RQ is up here, right? Which is a little bit weird. But let's talk about QS first, okay? So only thing we know is that QS is across from 37. Is QS going to be double or half of 37? It's going to be double, right? So measure of QS is going to equal double 37 because the arc is double the angle, right? What's that going to be equal to? That's going to equal 74 degrees, okay? All right, so we have that. So we know this is 74 degrees. Now, how do we find the measure of RQ? Well, let's think this through, but I'm going to use a different color here. What do we know about this right here? What do we know about that? That red part's a semicircle, right? Which means if QS is 74, how do we find the rest of it? Well, we can do measure of RQ, of arc RQ, is going to equal 180 minus 74, which is going to be the rest of it, which is going to be 106 degrees. Okay? That was a little bit tricky, but yeah, we're good. Okay, sounds good. All right. Why don't you try example 2, see if you can figure it out. Okay, we're looking for HJ. So HJ is across from, it's the arc that's across from 39 degrees. Is the arc going to be double 39 or half of 39? Yeah, it's going to be double of 39. So we know that HJ equals double 39 degrees, which equals what? 78 degrees. Okay, so we know this is 78 degrees. Now, what do we know about measure of angle HGJ? Well, that's going to be this angle right here. Is that going to be double or half of that? Well, the measure of the angle, HGJ, is going to equal half, 1/2 of 78, which equals what? Well, that's back to 39 degrees. That's interesting. So what do we notice about them? Well, these angles are both the same. They're both 39, right? So what can we say about that? Well, what we can say is that if these two angles intercept the same arc, this green arc here, we know that these angles are going to be the same, right? Because it goes double the half and double the half, right? So basically, if two arcs, so I should do a different color here. So if we use, let's use red. So if these two angles both intercept the green arc, right? We know that the angles have to be the same because they're going to be basically half of that arc, okay? So back here, theorem. If two inscribed angles of a circle are intercept the same arc, then they are congruent. So this is going to be ACB. Okay? All right, sounds good. Cool. Example 3, it says name two pairs of congruent angles in the figure. So I want you guys to give this one a try if you're able to. I would say focus on this arc and maybe this arc down here. See if you can figure out what angles are going to be congruent. Go ahead. All right, well, let's see. To intercept the pink arc, that would be angle P and angle Q. So angle P should be congruent to angle Q, right? Because they both intercept the pink arc, right? This angle and this angle both touch the pink one, right? If we go like this. And the green arc would be, which one? We'd have angle S and angle R. Okay, so angle S is congruent to angle R. Awesome. And that's it. Okay, we have some more checkpoints here. Why don't you guys see if you can try the checkpoints, and then we'll go through them in a second. All right, sounds good. So we're looking for angle GHJ, which is this angle right here. We know that this arc is 100. Are we looking for the arc or the angle? We're looking for the angle. Is the angle going to be half the arc or double the arc? It's going to be half, right? So we know it's going to be 1/2 of the arc, which is 100, which equals what? 50 degrees. Awesome. All right, how about CD? Are we looking for the arc or the angle? We're looking for the arc. Is the arc going to be double 40 or half of 40? It's going to be double 40. So 2 times 40 is going to be 80 degrees. Awesome. How about number 3? We're looking for angle RTS. We're looking for angle RTS. Okay, that's a little bit more tedious here, but not too bad. So all we know is that we have this angle right here, the 31 degrees, right? Well, we know that this arc right here is going to be, it's intercepting the same arc as the other angle. So if we want to, we could figure out that arc, which is going to be, this is going to be double, which is 62. And this angle is going to be half that arc, which is 31. But if these angles both intercept the same arc, we know they're going to be the same. So we know that it's just going to be 31 degrees. Awesome. All right. Couple more things here. If a right angle is inscribed in a circle, the hypotenuse has to be the diameter. So for example, AC is a diameter. And yeah, it's just basically like, yeah, if you have a right triangle in a circle, the hypotenuse has to go right through the middle and be a diameter, okay? And a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. What does that mean? They add up to what? They add up to 180 degrees. So these angles add up to 180, and these angles add up to 180, okay? All right, let's do an example here. We're going to do B. Well, if you want to try these, you can give them a try. We're going to try B together first, okay? All right, so for B, so this polygon is inscribed in the circle, which means it's on the circle. So we know opposite angles are congruent. So we know these, or sorry, not congruent, they're supplementary. So we know 8x plus 4x equals what? Equals 180. Oops. And we also know that 3y plus 3y equals 180. Why don't you guys go ahead and see if you can solve that from there. So 8x plus 4x is 12x equals 180. Divide by 12. X equals 15. How about over here? 3y plus 3y is going to be 6y equals 180. Divide by 6. Y equals 30. Awesome. Sounds good. Why don't you guys try A, which is very similar. Give it a try. All right. For A, we know opposite angles are supplementary. So x plus 88 equals 180. And y plus 100 equals 180. Why don't you guys go ahead and solve those if you didn't set that up that way. Subtract 88. So x equals, that's going to be 92. And over here, minus 100. Y equals 80. All right, sounds good. Checkpoint 4, don't like it. Don't worry about it. If you want to try checkpoint 5, go ahead and feel free. All right, so again, opposite angles in a polygon that are inscribed in a circle are supplementary. So we have 5a plus 90 equals 180. And also 4b plus 96 equals 180. Subtract 90. 5a equals 90. Divide by 5. We got a equals 18. Over here, minus 96. 4b equals 84. Divide by 4. And b equals what? 21. All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.